Today we are working on lesson 7.3 extension, which are angles and triangles, as well as the 7.4 lesson on quadrilaterals. Our I can statement for today: I can find missing angle measures in triangles and quadrilaterals, and I can construct quadrilaterals. All right, so we're going to start with the extension, which is looking at angles in triangles. And our key idea for today is the sum of the angle measures of a triangle is always going to equal 180 degrees. And they demonstrate that in the picture there. If you ripped off each of these three corners of your triangles and you put all of the corners together, the vertices of the triangle, then together they all form a straight line. So the amount of degrees in a straight line, 180 degrees, is the same as the amount of degrees in a triangle. So for our first example here, we're going to write and solve equations to help us find the missing value of x. Then we're going to classify each triangle, which means that we are going to give it two names, a name based on angles and a name based on sides. All right, so for our first one here, we have this red triangle, and let me grab a pen here. Okay, so we are adding the angles that we know, 28 plus 50 plus x, and then together they're going to equal 180. So when we add the two that we already know, because again we're combining like terms on the same side of the equation before we start doing things to each side, we have 78 plus x is going to equal 180. Then we're going to subtract 78 on each side to get that variable by itself. 78 minus 78 is 0, leaves us on that side of the equation with x. And then 180 minus 78 is going to give us 102 degrees, which means our angle marked x is going to be 102 degrees. Then we need to classify the triangle. So we have an angle here that's greater than 90 degrees, so that's going to make it an obtuse triangle. And then we have three angles of different size, and that means we're also going to have three sides of different sizes. So that's going to mean it's a scalene triangle. So we have obtuse and scalene for our triangle. Let's take a look at this one on B. So here we have a square marked in the corner. That means 90 degrees for that angle. We have one marked 45, and then we have this one that's x. So when we write our equation, we do need to write the 90 for the 90 degrees, plus the 45 that we know, plus the x, and that's going to equal 180. There are always 180 degrees in a triangle. We're going to combine the like terms that we have on the same side of the equation. 135 plus x equals 180. Then we are going to subtract. To cancel out addition, we subtract. So we're going to subtract 135 from both sides. We're going to get x equals 45 degrees. Don't forget that degree label on your answer. All right, so now we need to classify the triangle. We have a right angle, which means it's going to be a right triangle. And then we have two sides that are the same. You know that from the little lines here. We also have two angles that are the same. So that's going to make an isosceles triangle. So that's a right isosceles. All right, so for our next type of problem, same type of question, except this time we have two x's. We're still going to write an equation that equals 180. So here we have two x's plus 128 equals 180. All right, so now we have a two-step equation. We have to do order of operations backwards, which means we add or subtract first before we multiply or divide. So to cancel out the plus 128, we are subtracting 128. That is going to give us 2x on this side equals, and then when we do 180 and we subtract 128, we are, let's see, we'll borrow. Now, of course, if you want to use a calculator, you can too, but it doesn't take that long to do it this way. 10 minus 8 is 2, 7 minus 2 is 5, so we get 52. Then we're going to divide both sides by 2. 52 divided by 2 gives us 26. So x equals 26 degrees. It does say to classify the triangle. This one we have 2 angles that are equal and 2 sides that are equal. That's going to be an isosceles. And then we have one obtuse angle that's more than 90 degrees. So it's going to be isosceles obtuse. Doesn't really matter which name comes first. I could have written it as obtuse isosceles if I wanted to. All right, let's take a look at our next one here. So we have 2 x's. And then we have this 60. And then together they're going to equal 180 degrees. So we're going to subtract 60 from both sides. We're going to get 2x equals 120. And then we're going to divide both sides by 2. 2 divided by 2 equals 1x. And then 120 divided by 2 equals 60. So x equals 60 degrees. Now we need to classify it. Because all of these angles are 60, they're the same. That means all the sides are going to be the same too. They don't have them actually marked with little labels like they do here. But if all the angles are the same, that means all the sides are the same. So that means we have an equilateral triangle. And then we can either call it equiangular or acute. I'm just going to write acute because I don't have a ton of space to write right here. So equilateral acute, all the angles are acute angles and all the sides are the same. All right. Oh, I skipped one here. Okay, and then for our final type of problem for the 7.3 extension, you are explaining whether or not a triangle can have the given angle measures. And then if not, you have to change the first angle measure so that the angle measures form a triangle. So for this, what we need to do is we need to add our angles all together to see what they equal, and if they equal 180 degrees, then yes, they can be a triangle, and no, if they don't equal 180 degrees, then they're not going to be a triangle, and we'll have to adjust. So we're going to do 25 plus 64 plus 91, and we do get 180 for that total. You can use a calculator if you'd like. Okay, so can these work for a triangle? Yes, they equal 180. All right, so let's try our next one. We're going to start by adding our numbers together. Anything you put in a calculator, you do need to write down. So I have the problem written down. Okay, and I get 179 when I add those together. So can I make a triangle? No. And then it says to change the first angle measure. So this was 179. This first angle was 85. We're 1 short here, which means I would have to change that 85 to be 86. And then if I added 86 plus 64 plus 30, that would give me 180. All right, so go ahead and pause the video and try these 4 problems on your own. Okay, let's check our answers. So for number 1, we have x plus 41 plus 37 equals 180. Triangles always equal 180 degrees. We're going to add the 2 that we know that are on the same side of the equation. That's going to give us 78. So x plus 78 equals 180. We cancel out addition with subtraction, so we're going to subtract 78 from both sides. That's going to give me x equals 102. Now here they did not say to classify, so I'm not going to write it down. But if I was going to classify, this would be an obtuse scalene. All right, let's try this one. Here I have 2 x's plus 90 degrees, and that equals 180. So I start by subtracting 90. And I get 2x equals 90. And then I divide by 2. Remember, for 2-step equations, we're always doing order of operations backwards. 90 divided by 2 is 45. So x equals 45 degrees. If I was going to classify it, it would be isosceles, 2 sides equal, and right. All right, and then for 3 and 4, it says tell whether a triangle can have the given angle measures, and if not, change the first angle measure so the angle measures form a triangle. Okay, so I'm starting by just writing down my addition problem. I'm going to add my numbers together. 33 plus 140 plus 12 gives us 185. That is 5 degrees too many. So that's going to be a no. That means I need to subtract 5 from my 33 so that I have a number that's going to work to give me 180. So that's going to be 28. When I do 33 and I subtract 5, that's where I get that 28 from. All right, let's check on number 4. So I have 99 plus 53 plus 28. So I'm going to go ahead and enter those numbers into my calculator. And I get 180. So yes, that one is going to be a triangle. All right, so now we're going to move on into the 7.4 quadrilaterals part of our lesson. So the first type of thing they're going to ask you to do is classify quadrilaterals. So naming the quadrilaterals based on their sides, just like we did for the triangles. So there are some different types of quadrilateral names, and here I have kind of a diagram to help me keep them organized. So this giant shape here, that is a parallelogram. And a parallelogram has 2 pairs of parallel sides. So left and right side are parallel, top and bottom are parallel. And those, in order for those to be parallel, the ones on the side have to be the same length, ones on the top and the bottom also has to be the same length as each other. So that's what makes a parallelogram. Within the parallelogram, there are different types, kind of subcategories here. So inside the parallelogram is a rhombus. Rhombus must have 4 congruent sides. Remember, congruent means equal. So if you have 4 equal sides, that's going to make it a rhombus. It's also still going to be a parallelogram. Rectangle must have 4 right angles. And it's inside parallelogram because it is a type of parallelogram. If you have 4 right angles, it's going to be a rectangle and a parallelogram. And then squares here is in the overlap of the rhombus and the rectangle because it's both of those things. In order to be a square, you need to have 4 right angles and 4 equal sides. And if it's a square, it's also going to be a rectangle, a rhombus, and a parallelogram. So that diagram kind of shows the relationships between these things. There are 2 other types of quadrilateral names that are not considered parallelograms. And so that's why they're separate on this picture. They're not inside the parallelogram. So if you have a kite, it has 2 pairs of adjacent congruent sides. Both pairs of sides are different lengths. So the top and the bottom, the left and the right on the top are the same, and the left and the right on the bottom are the same, but they're not all 4 the same. That makes it a kite. And then for a trapezoid, it has exactly 1 pair of parallel sides. So the top and the bottom on this one are parallel, but not the 2 sides. Sometimes you see a trapezoid with the sides being parallel and the top or bottom being slanted. So trapezoid, 1 pair of parallel sides. Neither of those are considered parallelograms. All right, so for our first type of problem here, we're going to use our chart to help us. And we are going to classify our quadrilateral. When they ask us to do that, they want you to put all of the names that apply for that quadrilateral and then indicate which one is the best name for it. So this one has 4 congruent sides because I have these 4 little lines, so those are all the same. I have 4 right angles. So if I go back to my sheet here, 4 right angles and 4 congruent sides is a square. And a square is always a rhombus, a rectangle, and a parallelogram. So we're going to label it square. I'm going to give it a star because that is the most specific name, but is also a rectangle, a parallelogram, and a rhombus. It doesn't really matter what order you write your labels in. We do not need to label it quadrilateral. Quadrilateral means 4 sides. because it's in the directions. Just like on the triangles, we didn't have to write the word triangle because it was in the directions. Same thing. All right, let's look at B. I have two long sides that are the same and touching. I have two short sides that are the same and touching. So this one is going to be the kite. That is the only name besides quadrilateral that applies to that. So it is the most specific name as well. All right, here are 3 to try on your own. So go ahead and pause the video and write down your names for these quadrilaterals. All right, so let's check our answers. So for number 5, we have 4 equal sides, but we do not have right angles. So that means this is going to be a rhombus. That's the most specific name for it. A rhombus is also a parallelogram. Okay, number 6, these arrows mean the side is, these sides are parallel. So one pair of parallel sides, that's going to make it a trapezoid. And you don't really need to start when it's just one. That is the best name, but I went ahead and started since I was doing that on the other ones. Okay, here I have 4 right angles. But my picture tells me that the long sides are the same as each other, and then the short sides are the same as each other, but they're not all 4 the same. So that's going to be a rectangle because of the 4 right angles. But a rectangle is also always a parallelogram, so we're also going to write parallelogram. All right, so our next key idea is finding missing angles in a quadrilateral. So this is just like the triangle work we did earlier on in our lesson, but now instead of 180 being the amount of degrees, quadrilaterals always have a total of 360 degrees. So we add all the angles together and then they equal 360. All right, so we are going to find the value of x. We're going to write an equation. We're going to solve it just like we did with our triangles. 70 plus 115 plus 75 plus x equals, and then again for quadrilaterals, it's always 360 degrees. Okay, so we're going to start by adding together the like terms that are on the same side of the equation. For this one, it's going to be those 3 angles, 70 plus 115 plus 75, and that gives me 260. So my new equation is 260 plus x equals 360. Now I get rid of the addition with subtraction, so I'm going to subtract 260 from both sides. And I get x equals 100 degrees. All right. Did it say to classify? No, just wanted to double check. Okay, draw a parallelogram with a 60-degree angle and a 120-degree angle. So we're going to break out those protractors and do some more constructions today. So go ahead and pause the video, find a piece of paper if you don't already have one, and find your protractor, and then come back to the video when you have those things. So pause the video, go get your supplies, come back. All right, hopefully you're all ready to do this as I do it. So we're going to start with our parallelogram in a very similar way to what we do with our triangles. We're going to start by drawing a line. I'm going to give myself a ruler as well so I can actually do it nice and straight. Okay, so you're going to use the bottom of your protractor. I'm going to use the ruler just to make sure that I'm actually doing a straight line here. Okay. Doesn't matter how long you make it. The bigger you make that line, the bigger your parallelogram is going to be. All right, we need a 60-degree angle and a 120-degree angle. So just like with the triangles, you're going to take your protractor, you're going to line it up at the end of that line segment. You're going to find where it says 60 degrees. You're going to make a mark. We're using the 60 on the bottom because our angle is on the right side. Okay, so now we're going to rotate our protractor and line up the lines. Now I'm going to slide over here and I'm going to switch it to my ruler. But you can do this with your protractor. Now the thing that's different about doing a parallelogram versus a triangle on this step is it doesn't matter how long you make it, but you need to pay attention to how long you're drawing. I'm going to make my sides 4 centimeters long. So I'm going to start at 0. And I'm going to look at where 4 centimeters is, and then I'm going to stop. When I make my next side, I'm also going to need to do 4 centimeters. If I make that one longer, then it's not going to look like the top and bottom are parallel. Whoa. Okay, so now I'm going to take my protractor. I'm going to go back to the other side of my original line. I'm going to line up my center point, line up my line, just like I do for the triangles. Now I'm doing 120. My angle's pointing to the right, so I'm using the top. I'm sorry, this is the left. Oh my goodness. So my angle is going to the left, so I'm using the top side of my protractor, which is the 120. It is the same part of the protractor that my 60 was on the other side. When you're making a parallelogram, you're going to go to the same part of your protractor for both. On the right-hand side, it was 60. On the left-hand side, it's going to be 120, but it's still going the same way because our lines have to be parallel. So I'm going to move this out of the way. I'm going to go back to my ruler, and when I do this, I'm going to do it 4 centimeters, just like I did on the last one. So I need to line them up. Oh man. Best I can. Make sure these two sides have to be the same length as each other. Okay, and now that I've done that, then I can draw my line on the top. Your line should look parallel with the bottom. If it doesn't, that means you measured something wrong. Either you measured your sides wrong, these have to be the same side, or you measured your angles wrong. You do need to go through and label what they asked you to do. So here was my 60, here is my 120. So that's what yours should look like. I'm going to go ahead and label my top ones as well. You don't have to do that. But I am just to point out to you, on a parallelogram, the angles that are diagonal from each other are the same. So sometimes they'll say draw a parallelogram with two 60-degree angles. That doesn't mean both of them on the bottom are going to be 60 degrees. That means the one on the bottom and the one across from it, diagonal, are both going to be 60. These two numbers are always going to equal 180 degrees. All right, so let's go ahead and take a look at a few more problems here. So our last problems for today. Go ahead and pause the video when you get down to number 6. Right trapezoid means it has a right angle in it. Okay, go ahead and pause the video. Try these 3 on your own. Okay, let's check our answers. So for number 4, I'm going to write out all of the angles here. Plus x, and it's a quadrilateral, so it's going to equal 360. 100 plus 80 plus 100 is 280. Plus x equals 360. We're going to subtract 280 from each side. And we're going to get x equals 80 degrees. Now, if you remember what I said in the last one and you saw, hey, it's a parallelogram, these two are the same, these two are going to be the same, this is an 80. Yep, you can do it that way too. All right, let's take a look at number 5. Don't forget about this one in the corner, that's going to be 90 degrees. So we're going to write 81 plus 90 plus 124 plus x equals 360. All right, so I'm going to add the 3 that are together on the same side of the equation. So 81 plus 90 plus 124 gives me 295 plus x equals 360. Then I am going to subtract 295 from each side. All right, and then I'm going to do 360 minus 295, and that's going to give me a total of 65. Always a good idea to go back and look at your picture and see, does that seem reasonable there? Yeah, it does look like it's less than 90 degrees. If I had something that looks like this that was obtuse and I said it was 65, then that means I'm going to need to go back and double check my work. But here, 65 does seem reasonable for that one. All right, and then number 6, draw a right trapezoid whose parallel sides have lengths of 3 centimeters and 5 centimeters. Okay, so I need some drawing tools to help me out with this one. Okay. I'm going to start with my ruler. Okay, I'm going to do my 5 centimeters on the bottom and my 3 centimeters on the top. It doesn't really matter. Okay. Right triangle needs means I need a right angle. So 90 degrees, I'm going to make my point. I'm going to line up my sides here. Doesn't really matter how long I make it. I'm not going to make it very long just so that it fits into that space. Do that. Okay. Okay, so now I need to put in my next line. In order for them to stay parallel, that's going to need to be another right angle as well on the side. So I'm just going to use my protractor and make sure I've got a right angle on the top and on the bottom. Okay, so 90 degrees would be, is this lined up? Yeah, I think so. 90 degrees would be here. Okay, so now I'm going to take my ruler. I'm going to line it up. And this time I'm only going to draw 3 centimeters. And then my last step would be to rotate this so that it's lining up with the 2 sides. Come on, ruler. All right, so now I'm going to label the things that they told me to do. So right trapezoid means I need right angles. 3 centimeters I chose to do on the top, and 5 centimeters I chose to do on the bottom.